Mr. Talega. I am going through notes in section 3-1, the Cornell notes that you took in class. First of all, I want to thank you for tuning in and pressing play. I really appreciate it, and I think hopefully you will too. I know all I have is my voice here, but I just want to take a second to thank you for clicking in, and if it's for review purposes, that's awesome. If you missed a day, I think this is a good way to get yourself caught up. If you follow along and just do the best you can. I'm in my basement. If you hear the kiddos wake up and come down here, I might have to pause and come back. But just to listen, and remember that because it's a video, you can press pause and you can rewind and you can fast forward to get what you want. But I encourage you to listen because I think I'll go through stuff in a way that'll make sense. I'll try not to waste your time. So let's start with our learning goal, which is I can represent real life situations using standard form, which is ax plus by equals c. So let me type that in here, and you can set that up in your notes too, okay? So here we go. I can represent real life using standard. Yeah, I make spelling mistakes. You guys are gonna find this a lot. I'll figure it out usually, but just know that spelling is not my strong suit. Yeah. Using standard form, and it's ax plus by equals c. All right, let me neaten that up a little bit. So I'll drop this down a little bit so you can see it all in the line. Drop this down. This is the part right here that is what we're really talking about today. Make that yellow. Boom. So that's standard form, okay? And we're going to learn how to take these word problems, these situations, and put them into standard form, okay? So here we got our little problem right here, which is you have $12 to spend planning. This is the problem I'm looking at here. You have $12 to spend and plan on spending all of your money. You're going to spend all of your money on pop and candy. You can buy bottles of pop for $2 each and bag of candy for $1 each. How many of each could you buy? And then defend your answer by how do you know you have spent all of your money? So these word problems appear all the time, and we're going to learn how to create this. So what we want to do is make this into, we're going to figure out how many pops and how many bags of candy we need to buy in order to do this, okay? So let's create, let's try to defend our answer. Let's try to create, let's say that we wanted no pop at all and all candy. So how would we do that? So if we wanted no pops at all, we could represent that with a 0, right? Now we know that the candy costs $1 a piece, and we know that we have $12 total, right? So that's like our equal sign. It equals $12, right? That's our total, right? That's our money right there. I should make it look like money, right? So put like a decimal mark on it, a couple of zeros, yeah, dollar sign. Yeah, you get the idea, right? Okay, so, and what we're trying to do, then we could buy 12 bags of candy because they're each $1. Okay, take a second and just look at that. So we have 0 pops, and we have 12 bags of candy. Each one costs $1. Now we spent all of our money, right? Now let's say that we're going to buy 1 pop. Okay, now we've just spent $2 on that pop, right? That $2, because every pop is $2. So that means that this I don't have as much room for anymore, right? So this has to be a 10, right? Okay, I think I might have to shrink down my numbers a little bit here. Let me see if I can do that. Yeah, 24 will work. Yeah. And okay, so you get the idea. So now we got a pattern kind of started, right? You can kind of see that we're going, down by 2s in our bags of candy and up by 1s in our bottle of pop. So for every 1 bottle of pop, it's really 2 candies, right? So let me, first of all, hold on. I'm trying to make it so, whoa. Sorry. Yeah. If this looks like it's new to me, it kind of is. Do drag drop. Damn. No. Trying to do is get these that are 28s down to 24s. You can see that, I'm sure, so that they fit better in my boxes. But so then let's just go with our pattern. So here's our 2, and then we're gonna go 3, and then we're gonna go 4, then we're gonna go 5. Then we're going to go 6. So these are all pops, right? So they're all worth 2 candies. And then we're going to go 7. We can do that. Fine. Now over here, when we buy 2, we get 8. So we got 12, 10, 8. Then what do you think? 6? You bet. And then 4. And then 2, and then 0, right? And then negative, negative 2. Yeah. Okay. So these are all going down by 2s, right? That's what's going on here, okay? And these are all going up by 1s. So let's just take a look at that. That's called the recursive formula, right? Or the recursive pattern. So let me get my fancy pen out here. And yeah, if I take and look at the difference between these guys, these are all going down 2s every time. Down 2s. Down 2s. You know, minus 2 each time, right? Over here, what's going on? If I look at this, the difference between these guys is all 1, right? This is all plus ones. These are all plus ones. All right? So, how many pops and how many candies do you know that you have to spend all your money? So, the question is, how many of each will you buy? Well, the answer really depends, doesn't it? Okay. This we can graph, right? We can put this in standard form and then we can graph it. Basically, any one of these points can be a point on a number line, right? So let's set up our graph. We got candy over here on this side. And then on the bottom, we'll make this our pop. All right. And we'll put some numbers in here. I'm going to make my numbers smaller here. And I think I'll make them maybe a nice little blue. Sure. Okay. Or purple's good too. Here we go, purple. Here we go. So I got a 1. And I got a 1. And I'll make this a 2 here in a second. A 2. And a 2. And a 3. And a 3. See, this is probably the part where you could fast forward, right? Like, you could watch me, like, drag number 1s around, but that's really not that much fun. I suppose I could have handwritten these. Probably would have been a lot faster, but it also is so not neat either, so. I should have actually set all these numbers up beforehand. All right, now I'm going to zoom in here. 200%. So this one's going to be 2, be a 3. Right. Well, so okay. So let's graph this. When we had one, if we had, so when we had ourselves 0 pops, that's our X, we had 12 bags of candy. Let's go back over here so like we have like that fit on the graph. So when we had 2 pops, we had 8 candies, right? So 2 and 8. Grab my pen. So 2 and 8 would be here. So 2 pops and 8 candies. There's my dot, right? Then when I had 3, I had 6. So that would be 3 and 6. And then 4 and 4. All right. And then 5 and 2. What's going on here? Do you guys see a linear equation? 6 and 0 down here. Right? And we could go like 10 and 1, right? So this is making a line. So let's graph it to make it look like a line. And so, boonk. Right? Maybe not totally perfect, but that's a linear equation, right? Okay, so, and to represent this line, this equation, in our standard form, this is going to be 2x plus 1y equals 12. So 2x plus 1y equals 12. Right? For every 2 x's, it equals 1 y. Right? That's what we figured out there. 2 x's equals 1 y. That's our linear equation. All right? Ta-da! Okay, now let's go on to the next part. This is graphing using intercepts. So next page, go down to graphing intercepts. We got a little bit to set up here. First of all, we had an Alex assignment for this, which was worksheet Alex 1-5. So if you haven't done that yet, do that. Our learning goal for this thing is I can graph a linear function using function by finding x and y intercepts. So I hope you're hanging in there with me. I know this is kind of slow, but hopefully you've hit fast forward on my graph making and you're hanging in there with me. You can graph linear functions by finding the x and y intercepts. Okay, and our x-intercepts, we should maybe go through the questions quick too. Pretty easy. What is an x-intercept? What is a y-intercept? What is the... I don't think we're going to mind too much about that. Then how do I find the intercepts given an equation? I suppose it might be nice here to view this in kind of a full, like that, probably. I find the intercepts given an equation. Right? Those are 3 questions. The x-intercept is the x-coordinate where a line crosses the x-axis. So we'll talk about that, but the x-coordinate of where the line crosses the x-axis. And it is really kind of as simple as it sounds. It's like, you know what it means to intercept something. Like if the ball is intercepted in a football game, it was being thrown one way, and then where it crosses and another person grabs it, that is the x-intercept, right? So, yeah. This is the x-axis right here, right? This one that goes this way, this little dot represents where it crosses. So we're looking for where the line crosses the x-axis. And if you look here, we know that this is the x-axis here, right? And we know that this is the spot that it crosses it. So that little purpley dot is where that intercepts. That's where those two cross, okay? So likewise, then the y-axis is going to be where these things cross the y, right? Okay. And the y-coordinate of where a line crosses the y-axis. Right? 22 is 18. Okay, so now we're going to look at where the line crosses the y-axis. So here is the y-axis. And then this spot right here is where the line crosses, this line right here, crosses the y-axis. So that's the y-intercept, okay? So the x-intercept right here, it just says this would be the x, and this would always be, the y-coordinate would always be a 0, okay? So this means that all these points would always have, if you gave the coordinate pair of any of these points, like that one, well, that's too big, right? Or this one, 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 or this one. All those points are going to have a 0 in the y coordinate, right? Like if I gridded them out, it would all be like, every one of these points would be like, let's see, this would be like negative 1, 2, 3, 4. So this would be negative 4 in the x and 0 in the y. So all of these points would have 0 in the y, right? That their y axis, is x and y. Their y would always be a 0. 0, 0, 0, 0, 0, 0, 0 in the y. All those have a 0 in the y. Okay? This is where the line crosses the x-axis. So this one right here would be the x-axis. All right. Then over here we have crossing the y-axis. So what do you think the intercepts are going to be here? So in this case, our y-intercept, our x will always be a 0. This is the x-coordinate; it'll always be a 0, and then our y. So this is a 0. Okay. What that means is all of the points along this line here are going to be all these points here, like this one and this one. All of these are going to have a 0 in the x-coordinate. Okay, so like if I took this point right here and I did an x comma y coordinate pair, remember this is the x and this is the y, the x would be 0, right? And the y would be like -1, -2, -3, -4. But all of these, all of them, all the way up, would all be 0 in the x. Okay? 0 in the x. So all those are like 0, -4, 0, -3, 0, 0 and 1, 0 and 2, 0 and 3, 0 and 4, all the way up. Okay? Yeah. So that's pretty much that. So this would be the y. Yeah. So now let's find some. So we're going to go ahead and make this a little bit bigger. Highlight this out a little bit. So if I'm going to take this equation right here, 5x plus 10y equals 60. And I'm going to figure out the slope-intercept form. And I'm going to use, I'm going to plug in 0 for y. And I might say things like 0 out, which is the same thing. It's also called the cover-up strategy a little bit. So we have things, an equation here that's in standard form. We have 5x 10y equals 60. That's just like what we did on our last page. In order to figure out the intercepts, like in this case we're looking, for the x-intercept, we're going to 0 out one of these things. It means make it a 0, okay? So we're going to take our equation, and we're going to use this tool called multiplying by 0. So like whenever we multiply something by 0, we make it gone, right? So we're going to take our 10, which is our y, right? See that? Our 10y. But we're going to substitute for y a 0 to start, okay? So instead of the y, I put a 0. And this is going to equal 60. Now I have to do some freehand around this. But I got to move this one here. So now 10 times 0 cancels out, right? Because that's nothing. So that leaves us with 5x equals 60. Okay? And then you might be looking at this right now and know this is 12. And that's cool. That's fine. But realize that this is still just an equation, and 5 and x are held together by multiplication, and I'm going to use division to get the x all by itself. That's still my goal, is to get the x all by itself. That's how I'm going to know what that x-intercept is. So I'm going to multiply, or I'm going to divide, excuse me, because that's the opposite, by 5. And here, this cancels. 5 divided by 5 is 1. 60 divided by 5 is 12. Okay? So this would equal 12. That means that x is equal to 12. Okay, so I zeroed out the 10 and the y, because it's the y. I zeroed out the y and I'm left with x is 12. That actually means that the place where the line crosses the x-axis, this one right here, is at 12. This says x12. That means it crosses at x12. Okay, so like this right here, this piece right here, this would be x coordinate positive 12. I think this is like, I don't know, it would be over here. If you follow this line over, it would be somewhere in here. Okay, that's x12. Right, that's the x-intercept. That's what that is right there. That's where that goes. Okay, now we're going to do the same thing for a y. So we're going to take our formula again. Our 5x plus 10y equals 60. And this time, we are going to substitute for x. So instead of, we're going to zero out the x. So instead of an x, I'm going to put a 0 in there. Whoops. So now it's 5 times, this is supposed to be a plus sign. Whoops. Now instead of 5 times x, it's 5 times 0, which we know, right? 5 times, or 0 times anything is just gone. So we cancel that out, and that leaves us with just 10y equals 60. Alright, so we got 10y equals 60. Now your brains are probably way faster than mine, and you've already figured out that all we got to do now, 10 times 6 is 60, right? So, but, yeah. So basically what I'm doing is I'm going to divide both of these sides by 10. And then what I'm left with is 6. Right? So I have a y. That means this cancels. Whoa. So yeah, so like this. This piece cancels. Right? And that gives me just the y equals 6, because 60 divided by 10 is 6. So that means that this spot, this thing right here, oh no, I don't want a pen there, that this thing right here is where this crosses the y. So like here's my y-axis, right? I let my little, this goes up and down, right? Zoom, zoom. Like y-axis, and that's 6. So it crosses right 1, 2, 3, 4, 5, 6. Right up here. That's where it would cross. That is the y-intercept. Okay, I'll do it again for this one right here. 4x minus 2 equals 8. We'll use the same strategy, and I'll go kind of quick through this one, okay, or quicker, I guess. So first thing I'm going to do is zero out the y and then zero out the x. So basically these are all, like when I say x is 12, I know then my y is 0. Okay, so like if I had I'm backing up here to this, like if I were to create the coordinate pair for this one, like the coordinate pair, remember those are the ordered pairs. Ordered pairs, coordinate pairs are kind of synonyms. The x would be 12, right, and the y would be 0. And over here, the coordinate pair would be, the x would be 0, and the y would be 6. Okay, so those would be, where I would graph those. Now over here, we'll start with our new formula, which is 4y minus 2y equals 8. Okay, and I'm going to start by zeroing out the y. So instead of, oops, sorry, this should be an x. So instead of a y, we're going to have 0. Okay, and then when we multiply stuff by 0, it goes away, right? So this crosses out. So then we're just left with 4x equals 8. We divide both sides by 4. This cancels over here. 8 divided by 4 is 2. That means that x equals 2. Okay? Over here, we're going to go 4x minus 2y equals 8. And then this time, we're going to zero out the x. So I'm going to multiply by 0. And then what happens is, of course, this goes away, right? And that leaves us with negative 2y. Don't forget the negatives, right? They're always sitting there, and you got to get them. They're valuable. Equals 8. Now, I'm going to divide this by negative 2. Whatever I do to one side of the equal sign, I have to do to the other, right? Here, this cancels. And then over here, I have negative 2 and 8. That goes in there 4 times. And it's a negative because the signs are different, so it's a negative. So y equals negative 4. Okay? Yay. So you'll always have 2 ordered pairs. And remember, if you put them in coordinate planes, the other one would be like 0. So you'll have 2 ordered pairs. Okay. Now we're moving on to graphing these functions, which I think is pretty simple. So, well, I mean, okay, I shouldn't say stuff like that, should I? I mean, once you get it, once you're in learning mode, it's not always easy to be in learning mode, but we're in learning mode. We're looking at this one right here, okay? We're gonna find x and y, so we're gonna plug different things in here. Okay, so let's go here. Plug in for the y. So this is more using the cover-up strategy. Plug 0 in for y. this is kind of more like just covering up. I don't know how I can show covering up. So basically, instead of writing a y, I'm going to write nothing, a 0, equals. I'm just kind of doing that, like, what this next step is really is doing exactly what we did in the last page, but we're doing it a little bit more quickly, and we're just using the strategy. We know that if we multiply y by 0, it's just going to go away, right? So we don't have to do that anymore. So this is -4 plus 2x. So I took the y out, okay? So now I just have to get the x all by itself. So this is a little bit of a two-stepper, okay? So I put that negative on the wrong side. So grab a pen. What I'm really going to do here is try to, here's my happy couple. I'm trying to isolate this happy couple first. So what I have is I have a -4. Right, here's my equal sign, right? So I'm going to add a 4 to each side. This is just solving an equation. Okay, over here I have a 0, but now I'm going to add a 4 to that side. Now these cancel because that's a 0, right? So my new problem is 4 equals 2x. Here's my multiplication, so I'm just going to divide both sides by 2, right? And then these cancel here because 2 divided by 2 is 1. 4 divided by 2 is 2. So this is x equals 2. X equals 2. Okay. I got a little sloppy there. Let's see here if I can move this. And move it up here. Get it out of the way. Okay. Then let's find the y-intercept. So the same thing. I'm going to zero out the x. I'm going to plug in 0 for x now. Not y, but x. So I'm going to go y. This one's, I think, super easy because you can see it. Y equals -4 plus 2. And then it's going to be, I'm plugging in 0. So there it is. So then this goes away, right? So like this part here, 2 times 0 goes away. So look, if that's not there anymore, all that's left is y equals -4. And that's the intercept right there, staring us in the face. Okay, so then let me go over here. And we just said that our x was 2. So I'm going to go over here. 1, 2. This is my x-axis, right? There it is, x-axis. Here's a 1, here's a 2. Boom. There is my intercept. That is that, right? There it is. There it is. Boom. Over here I got y is -4. So here's my y-axis, right? Y goes up and down, remember? Like the little part of the y goes up and down. And we got -4. So -1, -2, -3, -4. Boom. So this is this intercept right there. And I can make a line. Yes, I can. I can make a line that crosses both of these. It's not exactly. Can I scooch it? Can I scooch it? Oh, I have to use my little feet, I think. Yeah. There we go. Right? That's the line that goes through there. And it would extend all the way, obviously. It's got arrows, so there it is. Now let's do another one. So we got 2x plus 3y equals 6. This is the one we're doing right here. So we're going to start by plugging in 0 for the y. Okay. So we end up with negative 2x plus 3y equals 6. Okay. Move some of the stuff out of the way a little bit. And so instead of the y, now we're going to plug a 0 in. So poof, it's gone. And so then this is negative 2x equals 6. Right? I'm going to divide by 2. Divide by negative 2, sorry, cancels. I got a y over here, and then negative 2 divided by 6, 246, equals negative 3. So if I find my y-axis right here, and I go 1, 2, 3, that's where my point's going to be, right there. This is right there. Okay, then let's do the same thing, but we will 0 out the x. Plug in 0 for x this time. Okay. So negative 2x plus 3y equals 6. But instead of the x, I am going to plug in a 0. Right? And then poof, this is gone. And what I'm left with here is 3y equals 6. I'm going to divide them each by 3. Right? This cancels. And then 3 goes into 6 twice, so y is equal to 2. So if I go over here and I look for my y-axis, oops. What did I do wrong? Did I 0 out? Oh, over here, this is not a y, this is an x. Youch. I'm sorry, I totally goofed you guys up. This is negative 3 on the x. I did this wrong. Hopefully you continue to listen, because I just messed up. Which happens, right? Okay, this is supposed to be an x. We canceled out the y, so we were left with the x. We did all of our stuff right here, but instead of this being a y, this is x. So I need to move this one actually over to negative 3, which is right there. I'll move this over here too. That is confusing. Okay, but basically this is an x, and here's our y, and our y, we did all of our math right. I did it all right, but I thought this was a y for a second, and I put it there. This is an x, goes there. Y is positive 2, so here's y, and we go 1, 2, and our dot is going to go there. Grab my pen. It's going to go right there. Okay, so this one is right there. So our 2 points are here and here. Okay, this one is the x, -3, and this is the y +2. And then I can draw a line through those two. Like that, right? Like that. Okay. There you go. Okay, and then now horizontal and vertical lines. This is the one I just covered today in class. I can graph horizontal and vertical lines. Your assignment was Alex 6 through 10. And the learning goal today is I can graph horizontal and vertical lines. Okay, and how do I graph vertical lines? That's our question. Vertical means up and down. I always just think of like a rocket ship, goes up and down. And then how do I graph? How do you rate the equations of a horizontal line? All right. I guess I can't find the Z today. All right. So here we go. So what we're going to do is look at this little piece right here. So it's a y equals 5, right? So that is an intercept. And what we're going to do is draw a line across all the points that would intercept that. So if we go on the y-axis, remember our y-axis is this one right here, the one that goes up and down, right? Because the tail of the y goes up and down. That's the way I remember it, like this, right? Tail of the y goes up and down. So this is our y-axis right here. And this point here tells me that our point crosses the y-axis at 5. So if I move my line, I count up 1, 2, 3, 4, 5. My arrow is crossing the y-axis at +5. And I can draw a horizontal line there so that all of these points along here are going to have 0 in, are going to have zeros. They're all going to be like this point and this point and this point. If we were to look at the coordinate pairs for those, they would all be like this. They would all be like 1 and 5. They would all have 5 in the y. So the x, remember x comma y, their x's would all be fives. or no, their x's would all be like 1, and then the y's would all be 5s. All of the y's would be 5s. Every one of these points, the y is 5, y is 5, y is 5, y is 5, because they're all running along this one. Y is, x is, -1, 5, -2, 5, -3, 5, -4, 5, -5, 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5. So they're all 5s across this way. All these points are 5s, but it only crosses the y-axis at 5, right? 1, 2, 3, 4, 5. Boom, there it is. Okay, so if we had to write an equation for that line, basically it's just saying what does the y equal. So this one, same thing. This is horizontal, horizon line, same thing. If I start at my origin and I count to where this line crosses the y-axis, it goes 1, 2, 3, 4, 5, right? So the equation for this line is -5. Y equals -5. Y equals -5. So if xy, my y here would always be -5. My x's would be all the way across this way. So these only cross one axis, right? So horizontally, it only crosses the y-axis. It doesn't cross the x-axis. So horizontal lines only cross the y-axis. All right. Now vertical lines. Hey, it's Oppositeville. All right. So vertical lines. This is vertical, up and down, like a rocket ship goes up and down. We're going to only cross the x-axis. So we're going to, graphing a vertical line, we're going to find, here's our vertical line. It goes up and down, right? Woo! And I'm going to find -4, because that's what this says right here. This says -4. It says find me -4. So I take my vertical line, and I'm going to go 1, 2, 3, 4, -1, -2, -3, -4, boom, there it is. So this point right here is -4 and 0. -4 and 0, right? Now these are all the points on here are going to be -4 in the x-axis. The y-axis will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8, 9 negative, but they will all have -4 in the x-axis, and it only crosses the x-axis. So that is vertical lines. So then graphing our vertical equation is basically, we look at the line and where it crosses the x-axis, and we go 1, 2, 3, 4, 5. Whoops, that's 6. Yep, 1, 2. So right over here, 1, 2, 3, 4, 5, 6. So it's crossing the x-axis at 6. That means the x-intercept is 6. All right. So again, just like in the other case, we got vertical lines only cross the x-axis, so they only have an x-intercept. And the first it was y, here it's x-axis. So they only have an x-axis. Okay? So graphing them is pretty simple. To summarize, we said that horizontal lines only x-axis, vertical lines the y-axis. I'll make that like neater and stuff. Neater and stuff. Using some complicated words today. Okay, and there you go. Thanks for listening. Hope you get your notes done. I have one more little one to do here.